Hello everyone, today we are going to start up with number systems. Number system is a numeral system which has various symbols, and these symbols are used to perform mathematical operations and calculations. We have various types of number systems like decimal number system, binary number system, octal number system and hexadecimal number system. Decimal means 10. So it has a base of 10. That means we have 10 symbols to represent any number in decimal number system. The symbols are from 0 to 9. Binary means 2. So it has a base of 2. And we have 2 symbols to represent any number, that is 0 and 1. Either the things are turned on or the things are turned off. That means it is either true or false. Now we have the octal number system. Octal means base 8. Base 8, that is we have 8 symbols from 0 to 7. Hexadecimal number system. Hexadecimal means 16. So a hexadecimal number system has a base of 16 and we have 16 symbols. The symbols are 0 to 9, then A to F. Now here A corresponds to 10, B corresponds to 11, C corresponds to 12, D corresponds to 13, E corresponds to 14 and F corresponds to 15. These are the 4 types of number system that we basically use. Now we begin with decimal number system. Decimal number system consists of 10 digits starting from 0 to 9 and it has a base of 10. This is the number system that we have been studying from our childhood. That means the day we enter the school, we start up our formal education. In mathematics, we start up with the counting, and that counting is a decimal number system, right? Any number in decimal number system or any number system has a place value and a face value, and both the place values and the face values are different. Face value is the symbol and the place value is the place at which that particular symbol is, like its unit place, tens place, hundredth place, thousandth place and so on. In our example, here we can see we have a number 246.45. The number 6 has a face value of 6, as well as here in this case it has a place value of 6. Whereas number 2 has a face value of 2 because it's symbol 2, but the place value for this 2 is 200 because it's at 100th position, right? So all the numbers are represented by their place value. Now here we have 246.45, which can be represented as 200 plus 40 plus 6 plus 0.4 plus 0.05. That is, the number can be written as 2 multiplied by 100 plus 4 multiplied by 10 plus 6 multiplied by 1 plus 4 divided by 10 plus 5 divided by 100. Or we can write these tens in the parts. Here we have 2 multiplied by 10 to the power 2 plus 4 multiplied by 10 to the power 1 plus 6 multiplied by 10 to the power 0 plus 4 into 10 to the power minus 1 and plus 5 multiplied by 10 to the power minus 2. So every number, every face value has a multiplication of 10 to the power. That is, the numbers that are towards the left hand side of the decimal point have 10 raised to the power 0, 1, 2, 3 in a increasing order, whereas the numbers onto the right hand side of the decimal point has 10 to the powers in the decreasing order in a negative side, right? So this is a decimal number system, and this is how we represent the numbers in the decimal number system. Then we have binary number system. It is the simplest form of number system. All the work that is being done in computer systems is done using the binary number system only, and it consists of 2 digits, that is 1 and 0, and it has a base of 2. A binary number can easily be represented by using a series of switches. Either the things are true or the things are false. And in binary number system, each single digit is called a bit. Binary digit, that is bit, right? When 4 bits are combined together, they form nibble. When 8 bits combine together, they form a byte. 16 bits or 2 bytes combine together and form a word, and similarly 32 bits or 2 words are called as double word. This we would be looking further with a proper diagram. Now computers use binary numbers 0 and 1 to keep the calculation simple and to keep the amount of unnecessary circuitry less, which results in the least amount of space, energy consumption and cost. Hence, everything that is being done in a computer system is done using the binary number system, and a computer understands only the binary language. Now we have the diagrammatic representation for this binary number system. Here, as you can see, a single digit, whether it is 0 or it is 1, is known as a bit, right? Group of 4 bits is known as nibble. Group of 8 bits is known as a byte. 2 bytes, that is 8 plus 8, 16 bits, is known as a word. And two words combine together to form a double word. Now, the bit towards the rightmost side of the number has the least significance. That's why it is known as the lowest bit. Similarly, as we see in a decimal number 246, 6 is on to the rightmost side and it has the least significance. That means it is at the unit place, right? And 2 is at the leftmost side, it has the highest significance, it is at the 100th place, right? Similarly, in binary number system also, the bit towards the rightmost side is the lowest bit and the bit towards the leftmost side is the highest bit. The lowest bit is also known as least significant bit, that means it has least significance, and the bit towards the left hand side is known as the most significant bit, that is it has the highest significance. Now we have the octal number system. Octal number system consists of 8 digits in base which are 0 to 7. It uses only 3 bits to represent any digit in binary and easy to convert from octal to binary and vice versa. That means any number that we want to represent in octal number system can be represented in binary using 3 bits, right? The main advantage of using octal number system is that it uses less digits than decimal and hexadecimal number system, and it is easier to handle input and output in the octal form. So at number of places, when we for example, in Unix, when we talk about the permissions, right, whether the user has read, write, execute permission, the permissions are mentioned in the form of octal number system, right? Hexadecimal number system, the word hexadecimal means 16. Now, this 16 means it has a base of 16 and we use 16 different symbols, 16 different digits to represent a number. The digits are from 0 to 9 and A to F. It's popular choice for representing long binary values because their format is quite compact and much easier to understand compared to the long binary strings of ones and zeros. Hexadecimal number system group binary numbers into set of 4 bits. Hexadecimal number systems are often used to represent colors within HTML or CSS. For example, say when we use color system, when we want to add any a color to any component in HTML or in CSS, we can write the color code in the form of their names in a hexadecimal format or in a octal format, right? So hexadecimal format are the format that is being used to represent colors in HTML and CSS. Similarly, the IP addresses, the MAC addresses, these which are used to uniquely identify any device on the internet, have the format of hexadecimal number system, because rather than having a long string of ones and zeros, it is better to make it compact using 4 bits, combining 4 bits to form one hexadecimal system symbol basically, right? And our work becomes easier and it is easy to read, update, write and work with. So this is all about hexadecimal number system. In our next video, we would be discussing about conversion of decimal number system into binary number system and the conversion of binary number system into decimal number system. Till then, bye bye and have a wonderful day.